All right, so let's talk through the process for rationalizing this denominator if it has a single term in it. All right, it's possible that right away you might just think when you rationalize the fifth root, the index has to be the same, the base has to be the same, and then you have to decide, well, the power and index have to equal each other. So this is 81 to the first. We need a total of 5 powers. We have 1 to begin with, so how many more would we need if you were setting it up this way? 4. Now, is that something that's going to be possible to do by hand without a calculator? I mean, if you can do that, I'd be impressed. I'd like to see it. Okay, so what you want to do is you want to do the first step of simplifying this, if possible. So the idea is to try to simplify your base into a smaller and easier to work with number. So let's say what you saw was your numerator is going to stay the same, but what if you saw that 81 is 9 squared? Okay, so if that's what you saw when you go through the steps to rationalize, you're now going to take the fifth root. The base is now reduced to a 9. Okay, and again, you need to work to get the powers to equal the index. So our index was 5. When we look at our original power, we had 2. So how many more powers do we need to add to 2 to get to our index of 5? 3. So if that's the way that you perform this, you need to take 9 cubed. Well, how many of you know what 9 cubed is right off the bat? Okay. Again, that's not something that's a mental calculation. Okay. So what you want to do is you want to look to see, is there a simpler way or an easier way? You always want to reduce it down to the smallest possible exponential base. So the way that you should approach this is to rewrite the base of 81. Now again, you could see it here too. 9 squared. 9 is still a perfect square itself. So 9 is 3 squared. So if you took 3 squared squared, you get 3 to the 4th. So now that's the smallest possible base you can work with. It's one that you can manipulate mentally very easily. So now when you rationalize, the index has to be the same, so fifth root. The base has to be the same, so 3. And now you need to identify how many powers of 3 do you need so that the sum of powers equals the index. Well, the index was 5. The original power was 4, so what do you add to 4 to get to 5? 1. So all you'd have to do to rationalize this is multiply top and bottom by the fifth root of 3 to the first. And so across the top, you get 5 times the fifth root of 3. And across the bottom, again, we have the fifth root of 3 to the fifth. If you follow the process of rationalizing, the index and power will always be equal, which means they cancel each other out, leaving just the base itself of 3. So this would be your simplified form. And now, if you did it either of these top ways, eventually you could still get to the same answer, but this is the simplest form, and that's what we're looking for on this. All right, questions on that process? Hopefully by showing you the 2 ways that were too complicated, you also were able to see at least the process of how to choose the number to rationalize with. Carson?
I'm kind of confused how you get the bottom 3.
To this one?
Yeah.
Well, so when you multiply across if you multiply across the tops, you get this top.
Yeah.
When you multiply across the bottom, what you get is you get the fifth root of 3 to the 4th times 3 to the 1st. And when you multiply 2 exponents with the same base, you do what with their powers? Okay. And so you get the fifth root of 3 to the 5th. And so once you get this form of nth root of a to the n, it's going to equal a. So that's how you got the 3 for that.